Alright, so this video is looking at intercept form of quadratics. So if we take a peek at the intercept form, we have an a value on the outside, and then we have two binomials. So it would be x minus the intercept on both binomials. So this x sub 1 and x sub 2 are going to be the x-intercepts. So the first thing that we need to remember how to do is factoring, which we're going to get a lot of work in class on factoring, and I will probably put a review out just for the factoring process. So the biggest thing to know and to look for on factoring is a greatest common factor. If you can get a greatest common factor out before you start factoring, it sometimes can make your life a lot easier. So we want to be able to identify the x-intercepts of a quadratic function. So we're going to have to put this standard form function into intercept form. So the first thing I want to do is look for a greatest common factor. So if we look at 3x squared and 18x, we can see that there's a greatest common factor of 3 and an x. So if I take out a 3 and an x, so we're essentially dividing both terms by 3x. So if we divide this first term by 3x, we're going to be left with an x. If we divide this second term by 3x, we're going to be left with a 6. So now we have it in intercept form. So we do have this here, which we could also write as this. X minus 0 is just x. So we don't have to write it out this way, but it helps some of us see what the intercept would be. So intercept form, you can write it this way, or you can write it the way that I had it initially. I'm just going to do that. Or like I said, you could write it like this. So now if we look at the intercept form, one of the zeros, so x-intercepts and zeros of a function, it means the same thing. It's just two different ways of saying it. And there are other ways of saying it too that we will look over. But for right now, let's just focus on zeros and x-intercepts. So the x-intercepts would be just the number that's here. So the first one's going to be 0. So we have 0 and 0. Okay. The x-intercept always has a 0 for the y value because on the x-axis, the y value is always 0. And then if we look at this next one, it's x minus a positive 6. So it's a positive 6 for the intercept. So x is 6 when y is 0. And that's what we look at, because we have to remember the format. If we look back up here, it's x minus x sub 1, and x sub 1 is the intercept. So we got to think opposite of what we see. It's kind of like what we did with transformations. When it's inside the parentheses, we have to see that it's the opposite. So now when we factor this one out, so there is no greatest common factor, but we do know the special form from Algebra 1. We have x squared minus a number. So this number here is indeed a perfect square. So all we have to do is take the square root of that, which is 5. So we have x minus 5 and x plus 5. Because we know if we check this and we multiply this out, that middle term cancels out because we'll have a negative 5x and a positive 5x. And we combine like terms, it goes away. So intercept form is just this, so you can go ahead and write that down here. And then the x-intercepts, we're going to have a positive 5 from this one, and then we're going to have a negative 5 from this one. So 5, 0, and negative 5, 0. That would be your intercepts. Okay? All right, moving to example 2. Okay, we're going to do the same thing. We're going to factor it out into intercept form and then identify what the x-intercepts are. We just have to approach it a little bit differently because of we're dealing with 3 terms now. So the first thing we try to do is factor out something that they all have in common, which they don't. We can't factor out anything, so we have to go ahead and factor. So the nice thing is the first term is always factors of the first term here. So the first term in each of these binomials is just the product of this. Just like up here we had this x squared, and then we had x times x is x squared. So we only have 1 right now, so it has to be 2x times x. That's the only way to get 2x squared. So we can go ahead and start off here. 2x times x. And now these 2 spots are factors of positive 6. And we're looking at factors of positive 6 that in conjunction with this 1x and this 2x, we can add it together and get a 7x. So there are many different ways to do this. So right now we're just going to do basically a trial and error method. We're going to think of factors and then check them to see if they work. There are other methods which we will go over at a later time. So factors of 6. So we could have 6 and 1. So let's go ahead and try that. So if I put a 6 here and a 1 here, now what I want to do after I put that is to check to see if it works. So I'm checking right here. I'm checking this multiplication. So 1 times x is 1x. And then 6 times 2x is going to give us a 12x. Well, if I add those together, we get not 7x. So that is not going to work. So we can go ahead and back off of that. And then we could flip it in the other direction. We could put a 6 here and a 1 here, and then do the same thing. But 6 times 1 is 6, and then 1 times 2 is going to be 2. It's closer. We have 8, not 7 though. So now we got to think about factors of other factors of 6. So 2 and 3. That's the only other factors of 6, so that's got to work. We just have to figure out the order that they're going to be in. So let's say we put a 2 here and a 3 here. Is this going to work? Well, if we multiply here, we get 3x, and if we multiply here, we get a 4x, so 3x and 4x goes together, and that makes 7x. So that does work. Okay, so we have a positive and a positive, so it has to be both are positives because positive 3 times positive 2 is a 6. And then what really dictates it is this positive 7. The only way to do that is to have both of these positive. So this is our intercept form. Okay. So intercept form is 2x plus 3 and then an x plus 2. All right. So let's talk about this one first. So this x plus 2 is really an x minus a negative 2. So we have an intercept of negative 2, 0. And then this one, so the formatting is a little off. So what we have to think about is how do we want to rewrite this intercept form. So let's get rid of this. We want it to be in the same format. So x minus a number. So how do I do that? How do I get this 2 out of here? Well, it's like example 1. We can divide out. What can we divide out to get it in the format? Well, this 2 is kind of messing stuff up. So we got to divide a 2 out. So if I put a 2 out front, I'm just going to drop this second one down here. If I take a 2 out, I'm dividing by 2. So 2x divided by 2 is x. So that's exactly what we want. We don't have a number in front of x. And then this 3 divided by 2, well, that's just a positive 3/2. Okay, and that's the way we leave it. So we can write that down here. So the key is to have two binomials with x and no coefficient in front of x. So we have to divide that out. And now the intercept is going to be a negative 3/2. 0. Okay, so not always a whole number. Sometimes we have fractions. Sometimes we even have decimals. I mean, we're not going to get decimals out of here. We just leave it in fraction form. All right, so let's go ahead and try this next one. So we have a 10, a 6, and a negative 4. Well, all those are divisible by 2. So it's going to make it easier if we divide by 2. I'm dividing everything by 2, but we have to have that out front. Okay, we can't just get rid of it. So if I divide everything by 2, that's going to give us a 5x squared plus 3x minus 2. Okay, makes the amount of factors of the numbers that we have to think about a lot less. So factors of 5, well, there's only 5 and 1 because it's prime. So we know that it's going to be 5x and x. And then the other nice thing is we have 2 factors of 2. Well, that's 1 and 2. So we just have to figure out the order. So there's not a whole lot of error, or a whole lot of trial. The fact that this is a negative 2, which means one of these is going to be a positive number, one of these is going to be a negative number, so we have to figure that out at the end. So 2, if I put a 2 here and a 1 here, we'd have a 1x and a 10x. Is that going to work? No, because we're subtracting, remember? So they're opposite signs. So 10x and 1, that would give us like 9. So that's not going to work. So let's flip it around. So 2 and a 1. So 5x times 1, that's 5x. And then 2x, if we take the difference, that is 3x. So that works. We just have to figure out which is which. The fact that we want a positive number in the middle at the end, which means our bigger number has to be positive, so that 5x has to be positive. The only way to do that is to have a positive 1 times a positive 5. And then a negative 2 times 1 would give us a negative 2. So 5 and negative 2, that adds up to be 3. So we're good. This 2 drops down, because we need it here. And then to finally get it in intercept form, remember, we don't want a number out here, so we need to divide that out. So I'm factoring it out. So whenever you factor something out and there's already something out front, they have to be multiplied together. So if I'm taking a 5 out, I have to multiply it by this 2. Okay, so actually I'm just going to write that out just so everybody can see, so we don't forget. So I'm dividing a 5 out of here. So that leaves us with 5/2. And then still an x plus 1 over here. And then the final intercept form would be an a value of 10, x minus 5/2, and x plus 1. So now we can identify the intercepts. So we have a positive 5/2 and a negative 1. All right. So I'll go ahead and do the checkpoint and pause the video. All right. So we've checked to see if there's a greatest common factor, and there's nothing that I can pull out of all 3. So we got to factor this out. So factors. Go here and here. So 6x squared. So we have to think about factors here. So let's try a 3x, and a 2x. Factors of 4, so 4 and 1, or 2 and 2, we could do that. So 4 and 3 would be 12, 1 and 2 is 2, so 12 and 2, 14. Or even if we're going to have to subtract them, so that's even less, so we're off. So we need to go back, try something else. So let's try 6x and an x. And then 4 and 1. 4 and 1. Let's see. 4 times 6 is 24. And then a 1. We can subtract those to get a 23. So good. Now we need to think about what the signs are. So a negative 23, which means the bigger number out of the product needs to be negative. So 6 times a negative 4 would give us negative 24. And a positive 1 times 1x, that would give us a positive 1. So that would end up being, when we combine like terms, a negative 23. So here are the factors. We have one more step. We have to get this 6 out of here. So divide the 6 out. Ends up with a 1/6 and an x minus 4. Sorry, I meant to write that down here. That's the intercept form. And then the intercepts would be a positive 4 and a negative 1/6. Okay. Example 3. So we're starting off a little bit differently. So this time we're starting with the vertex form, and we want to convert it to intercept form. So write the functions in intercept form and then find the x-intercepts. So we're at the end, we're doing the same thing, but to get there is a little bit different. So first thing we need to remember, x plus 2, quantity squared, what that really means. That really means x plus 2 times x plus 2. So we have to multiply that together. This negative 9 is still hanging outside. We'll deal with that later. So multiplying these together should give us a x squared plus 4x plus 4. And then we're going to subtract that 9, so we end up with a negative 5 for our c value in the standard form. Okay, so now that we are in standard form, we have to factor. So it's a little more work when you're starting in vertex form to get to intercept form than it was starting with standard form. So now, this is a little simpler than what we were doing. So x times x, that's the only thing we got. So x is here. And then factors of 5, well, 1 and 5, that's it. So 1 and 5, doesn't matter the order, because we have a 1x and a 1x. Now we need a positive 4 out of it, so that is going to be a positive 5 minus 1. It's the only way that's going to work. So there's our intercept form. Now we identify intercepts as 1 and negative 5. Alright, going on to the next one, we're going to do the same thing. X plus 1 times x plus 1. We end up with x squared plus 2x plus 1, and then minus 25. So we have a negative 24 on the end of x squared plus 2x. That's a square. All right, now factor. Factors of 24 that I could subtract to be 2. 4 and 6. 4 and 6 works. It's all about trying things, seeing if it works. So 4 and 6. Now what do we need? We need a positive 2, so we have to have a positive 6 minus 4. Gives us a positive 2. That's our intercept form. So we have a negative 6 for an x-intercept and a positive 4. All right, go ahead and try the checkpoint there. Pause. All right. So a little bit more work than what we were doing in the examples. We have x plus 3 quantity squared, and then we're multiplying everything by 3, and then subtracting 3. So a little bit more, but we can handle it. X plus 3 times x plus 3 is going to go in here. So we end up with x squared plus 6x plus 9. All right, so now we multiply everything by 3 and then subtract 3. So 3x squared plus 18x plus 27 minus 3. So I'm just going to write the 24. All right. So now that we've multiplied by 3 and then we've subtracted 3 at the end, now we can try to factor. Before we factor, we always want to check if there's a greatest common factor. So between 3, 18, and 24, there is a greatest common factor of 3. Now, you're probably asking yourself, why didn't I just keep the 3 out and then, do something here? Well, you really can't. It just so happens that it's the same factor that it was before, but we still have this negative 3 in here, so it's impossible to do it beforehand. So take a 3 out, so we have x squared plus 6x, and then 24 divided by 3. Okay, so 8. And then factor this inside. We have let's see, factors of 8, that would add up to 6. Well, that would be a 2 and a 4. They both have to be positive. So there is our intercept form there. And then our intercepts would be a negative 2 and a negative 4. All right, hopefully that worked out for you. Example 4, so I'm dealing with the last example here, and then get your checkpoint done, and then that'll be the end. So write the quadratic function in intercept form whose graph is given below. So as opposed to starting with a function and then writing intercept form, we can look at this graph and figure out what the intercept form would be. So we know what the intercepts are. We can see them on the graph. We have a positive 2 and a negative 5. So the first thing we're going to want to do is we write x minus 2, and then we have a negative 5 has to go in here. So remember, x minus negative 5 is going to be a x plus 5. Okay, so there's the first part, the easiest part. Now what we have to remember to do is find out what the a value is. We can't just leave it like this, because this could be for really an infinite number of quadratics that would have these two intercepts, but we need to account for how big the graph is. So this other point is going to help us. All right, so let's go back and look at the formatting. So we have f of x, so we all know that's a y, and then we have some x's in here. So we have to start filling in some knowns so we can find the unknown. The unknown right now is a. How are we growing? So what we have to do is we have to have this as an unknown, okay? We have to set it equal to the y value. Now the y value is going to come from right here, this other point on the parabola, Okay, we can't use our intercepts. That's not going to work. We have to have another point. So the other point given is -4, -2. Well, the y value right there is a -2. And then the -4, we're going to have to plug in to these x's. So we got to get rid of these x's. All right. Probably wondering why I wrote them there in the first place. It's just to show you how to set this up. Okay. Oh, I started writing them again. Look at that. So we're plugging -4 into both x spots. Okay, because that's a known point. It's a known value. So now we have everything filled in except a, and that's what we're going to solve for. So now we can just do some algebra here. So now we have -4 and -6 go together and make -6. -4 plus 5, that would be a 1. So 1 times -6, that's -6. So we have -6a equals -2. Then we're going to divide by -6. So -2 divided by -6 is a positive 2/6 or 1/3. So the a value is 1/3. We're not done. We have to write a quadratic function. Okay, this was just finding a. So we have to come over here. I'm going to go red. This is the answer to the problem. So you can call it whatever you want. F of x, g of x, h of x, some letter. So f of x equals a, which is, we just found, 1/3, times x, and we're going to write it the way we had it before, x minus 2 and x plus 5. So we've just created a function. Well, we didn't create it, but we were able to write the function from a graph using our standard form of a parabola. So that is the answer. Sometimes they would ask for it in standard form, so you're going to have to go further and multiply this all together. But this is the most important thing out of all of this, is finding the a value, knowing where to plug things in, and getting a final answer of a function. So go ahead and pause and try the checkpoint, see if we can get that. All right, we're back, and hopefully this all went well. So let's go ahead and go down a little bit. So we're writing a quadratic. So the first step is to plug in what we know. All right. So we know the y, and we're going to get that from right here. So the y is -4. The a is the unknown. Okay, so we have our parentheses, x minus x1. And the x is from here, so 0. That goes into both spots. And then our intercept here. And we're going to subtract our intercept, which is 2 and 4. Now we have to clean this up. We know 0 minus 2 is -2. 0 minus 4 is -4. So -4 times -2 would give us an 8. So we have 8a equals -4. And then when we divide this, we get a -4/8 or a -1/2. Now we can plug our a value back in and our intercepts and get a final answer. So f of x equals -1/2 times x minus 2 times x minus 4. All right, that concludes the video. If you have any questions, just let me know.